Hello and welcome back. In today's video, we'll continue COMSOL user interface, and this is the part 4. And in this video, I'll be explaining model builder settings and graphics windows. So let us start this video. So first of all, let's open the COMSOL Multiphysics software. Now this is the software. Let's click blank model and start with the blank model. So this here is the model builder. This is the settings window and this is the graphics window. And these are here message, progress and log windows down there. So let's start with the model builder first. So first of all, this is the root folder here. This is the stem, like stem of a tree, and now we will keep on adding it as branches, and that's why this is called a model tree sometimes. So each branch is called a node. So here it says untitled.mph. Untitled means it has not title yet. We have open a file but we have not saved it. We can save it as and give it any name, and we can save, and it has this name. And .mph is the recognition of the COMSOL multiphysics file. It's the extension for multiphysics file. So if we expand this node, we have these subnodes inside it. These are like branches on this stem. Now these come by default with it. So by default these two nodes are with it. So whereas we solve a problem, we keep on adding different steps, and these steps will appear in the model builder, and those steps are important. These steps are very important to appear in the model builder. So because we can hover over these nodes and select any node at any time, and when selected, the settings of that node will appear in the settings window, and we can set in any of its properties. Here we can change dimension, change material, anything we can change in the settings window. And whatever geometry we are making here, we set set the coordinates, set the dimensions for that geometry here, and that geometry finally will appear in the graphics window here, so that we can see and make any changes if necessary. And another purpose of this graphics window is we use this graphics window to select different edges, points, corners, or different faces of the model for a different purpose, for applying boundary condition and other things. So for example, if we try to solve a problem which is like a heat transfer through a metal rod. So first of all, we know it's a three-dimensional problem. So we could add component at 3D. So we added a three-dimensional component here, which says component 1, which is 3D component. Now we know that it comes with definition, where we define variables and these variables and functions. I'll explain the later videos. Then we can define geometry. We can make a geometry here, change its units for the dimension of the geometry, and right click on the geometry. I can build a say cylinder, and I can give its radius 1 meter say, or height 10 meter, and height 10 meter. And position 00 means it is on the position on the origin, and I can change this or position of the cylinder, and I can make its axis along x-axis, build all, and we have this cylinder here. So this is what it means. Step gets added here, its settings appear here, and the result, the model appears here. We can rotate it with the left click, hover it with the right click, zoom in out by clicking the wheel, forward zooms in, backward zooms out, and we can use right click to pan it. I want to have the default size. I can click this and I will get here. First of all, let's move now on. So first of all, what I want is I want to assign material to this cylinder. So I go to material section, right click, add material from library. It opens the library. I search the material here. Say I use copper. I add it to the component. It turned into blue color from gray, which means material has been assigned. After material has been assigned, I can add study has not been added yet. It is a heat transfer problem, so I add study. Sorry, not study first, I meant physics. So we go to the physics section, I add physics, study comes later. I add heat transfer in solids, add to selection. So as I added to the selection, this grid did not change blue, which means the study has been added in the model builder but not assigned to this. So it is selected here, I click here, now it is assigned here. So now study has been added. I can apply the boundary conditions to solve this problem. I can boundary conditions applied by right clicking this physics that we have added, and since it's heat transfer, the boundary conditions will be like thermal insulation, heat flux, temperature. So I click temperature, I click this phase if I want to apply this temperature condition here, and I can set the value here, say 200 degree Celsius in parentheses. That means there's a code for degrees Celsius in here. Then I select physics back, right click temperature, and I can set this temperature condition on the other side and change the value from, say it is 20 degrees Celsius, 20 brace, square bracket start, TEG capital C square bracket close. Now we have assigned the temperature. Now if I do not assign the boundary condition on these lateral surfaces, it will treat them as thermally insulated. That is the default setting of COMSOL. That is why this thermal insulation will always appear with the temperature, heat transfer in solids physics, and temperatures will not be there or any other boundary condition, because if we want to apply them we have to select them. But if we do not apply any boundary condition to any surface, that is by default taken by this thermal insulation boundary condition. So I selected this temperature for this side and temperature for that side. Rest is blue, which means rest is applied with thermal insulation. So if we forget any surface to apply any boundary condition, so that problem will not be solved by COMSOL or any other software. But what these softwares does is they keep, for example, at least this COMSOL, it has kept this thermal insulation option always on, always applies to entire geometry, and when I applied this temperature condition, it got overridden on this selection, on this surface one, which is this. So it changed it from here, the surfaces, this cross section's boundary condition changed it from being thermally insulated to temperature boundary condition. In the same way this, so we will make it one time heat transfer and leave these lateral surfaces as thermally insulated. And even we can see this option thermal insulation is not even deletable, there is no option, rest we can delete. So this is by default there. So in case we forget any surface to apply boundary condition on, so it will be thermally insulated, so that we can still run the simulation. Now we have done everything. Now what we have to do is we can apply mesh and build. So now this is meshing, we have discretized this domain, and now it will COMSOL will solve the equation for each element. Now for that we have to add study. How do we want to make those COMSOL? How do we want COMSOL to study this? We add study, whether time dependent, whether we have applied the time varying boundary condition. So we want to make it to solve it over time, so time dependent. If there is no time involved, then stationary. Add study, it gets added after the mesh. So when the study is added, then we have to click compute. We have to start solving this problem for us. It will take some time, and this give us this temperature distribution in the form of this color. Even we can change this color setting. We can go to here, temperature appears when we it was not there before we computed. So after computing, this will appear, this temperature. Then we can open its node, select this, and we can change. This is heat camera light. This is a way of showing us the distribution. We can click the option and we can change the classical rainbow style here. So this is the temperature distribution in the form of colors, and bar shows us. We can even go to select a temperature and check these maximum minimum values and the units as well, show units. So maximum temperature inside this rod is 473 Kelvin, and minimum is 293. And where is maximum? Where there is dark red, which is this side, and least is dark blue, which is that side. In between, temperature varies from this side and to that end. So what does this model builder do? Every step we add gets added here, and we can hover over these nodes and select any node, and we can see it is settings here and change any of the settings. Material here, geometry here, and settings is the window where we apply the settings. Then whatever model we get is shown in this graphics window that we can see, and we can even select, deselect from this window. Now there are these options that we can check. For example, if we want to zoom in, first option, zoom out, second option. Now suppose I want to focus on this particular detail here, so we select third option, keep left button clicked, then extend it to enclose that particular portion that I want to focus on, so it will zoom that portion. So it zoomed that. So clicking this option here will take us back. Then we have this. I'm not showing all the options, only the relevant. We'll go there. These are three views: top view, like side view, top view, side view, top view, and another front view. And these can also be seen here. This does the same. Then if I want to see the main 3D view, I click this icon here. Then suppose I want to select everything, so this clear every selection, then this. Suppose if I want to, suppose right now I selected this side to apply boundary temperature boundary condition. I was able to select it because it is exposed. But what about if I want to select something from inside? So this is where this option comes in. I click it and I use cut plane. I cut it using like a rectangular cutter or spherical or cylindrical cutter. Suppose I use this cutting plane, and I can even change the location of this plane. I can cut it here at this section, or at any section where I want to see in the inside, and select anything. I can go back and delete this plane. Then I can see through this wall as well. I selected this and it makes wall is transparent so that I can see what is happening inside. Then there is also, I can see only the outline using this option. I can make this coordinate system disappear by clicking this second last option and bring it back. And this grid system, I can make it disappear from the last option and can bring it back. Then suppose this model is ready, I want to save it, I want to take a screenshot. So this option here, I go here, file name, I browse, select the location where I want to save it, then click save. I can also print it from here directly. I can also change the theme of this background by going here, select a dark theme or whatever theme. Now we have here is messages window here. So this message window shows us these direct little messages related to this problem, like solution time was 5 seconds. That means it solved this model for us in 5 seconds. Mesh consists of 3 5 2 1 domain elements. There were these number of elements, this number of boundaries. So it shows us these direct messages, warnings as well. But if we want to see these warnings or any errors in detail, then log, we click this log window appears. It shows us detailed information related to this, how many seconds, what physical memory it has occupied, this problem has occupied virtual memory and all that. And this shows the detailed progress of this simulation. So this was all about this last video about the user interface, which was about model builder, settings, graphics, and these message and log windows. Now in the next video, what we are going to do is we are going to start to solve a problem, but we'll solve each problem in two ways. We'll try to at least to solve each problem in two ways. One way we will solve, suppose we'll start with heat transfer, heat conduction through solid rod. And we will first of all solve it analytically using pen, using equations that we study in academics. We will solve it using Fourier's law. We will find the temperature distribution. We'll find temperature at a particular section of this rod, and we will find the temperature distribution or heat transfer rate. Then we will come to COMSOL, use the same details, solve the same problem using COMSOL, and find the heat rate using COMSOL, and find temperature distribution, and find temperature at a particular section. And then we will compare this numerical solution of COMSOL with the analytical solution that we have found, and we will see how accurate these numerical solutions are.